Okay, today we're going to talk about solving inequalities, which is chapter 1, section 5. What is an inequality? An inequality is essentially anything that does not have an equal sign. It's a statement where the right and the left side are compared, but they are not equal. The inequality symbols that we would be using are equal than, less than, greater than, less than or equal to, or greater than or equal to. Now, if I were to give you a number line and I put 0 in the middle of it and I draw an arrow to the right, the numbers to the right of 0 are larger than it, meaning the greater than symbol. Please don't use any Pac-Man or alligator symbols to understand that. If I draw an arrow to the left of 0, all these numbers are less than 0, so therefore that is a less than symbol. So please be very careful and understand we're not going to use Pac-Man and alligators, okay? Graphing. A closed dot indicates that the number is included and it can equal that value. So a closed dot is going to be used with less than or equal to, greater than or equal to, or equal to symbols. Now, an open dot is a number is not a solution of the problem. It excludes the value. So therefore, it's just going to be an open dot is less than, greater than, or not equal to. Okay? Now, these ones right here are going to be some symbols which we're going to use when we're talking about interval notation. Interval notation looks like an ordered pair with either parentheses or brackets around it. Infinity is the largest number in the world. So since it's the largest number in the world, we only use parentheses around it. So we do never, never, never put brackets around it. We always use parentheses. Negative infinity is going to be the smallest number in the world. This is excluded. This is included. Now, whenever we're using interval notation, include now turns into brackets. Exclude now turns into parentheses. Okay? Example. I give you set notation. Set notation says that x can be any number it wants to be, hence x is the number of the real numbers, when negative 12 is less than or equal to x, which is less than 14. What do I mean by that? Well, at negative 12, I'm going to have a closed dot because it can be negative 12. But at 14, I'm going to have an open dot, and then I'm going to simply shade in the middle between these two values. That is my solution set. However, if I give you the interval negative 12 with a bracket around it and comma 14, it's still exactly the same thing. The bracket means closed dot, and then the 14 is going to be an open dot. And you're going to shade in the middle. Okay? You're going to shade in the middle. Those are exactly the same notations. They're exactly the same number line with different notations, though, but they mean exactly the same thing. Now, the most important rule when solving inequalities, when you multiply or divide by a negative number, you must flip the inequality symbol. Why do we flip the sign? To make the statement true. That's why we flip it. An example. Here we go. How do I solve this? So the way I'm going to do that is I'm going to take x plus 5 and keep it there, distribute the 3, 3x plus 9 minus 10. Drop down the x plus 5 again and combine like terms on the right to give me a minus 1. Take the smaller x over to the other side by subtracting. Drop down the 5. It's greater than or equal to 2x minus 1. Add the 1. 6 is greater than 2x. Divide by 2. 3 is greater than x. Now, I do not like the way that looks. So what I would do is I would pick this up and say x, the arrow was right here pointing toward the x. So it's still going to point to the x whenever I pick it up and move it. So I have x is less than 3. So my set notation is x is an element of the reals, and x is less than 3. Or, here's my number line, here's 3. I have an open dot, and I shade down. Or, you could go ahead and say, well, I can have my number line be a 3 here and have a parenthesis shading to the left. Or I could say this starts at negative infinity and goes all the way to 3 with a parenthesis, and that is interval notation. So still all the same things. So let's keep going. R over 6 minus 5 is greater than or equal to 7 plus R over 2. The very first thing I notice about this problem, I have fractions. We don't like them, so how do I get rid of them? I multiply by the LCD. The LCD between 6 and 2 is going to be 6. So if I multiply this is a fraction, so I divide. 6 divided by 6 is a 1, drop down the R. This is a whole number, so I multiply. greater than or equal to. This is a whole number, so I multiply. This over here is a fraction, so I divide. 6 divided by 2 is going to be 3, drop down the r. Looks so much better already, and now I'm going to solve this outright. I bring over the smaller r, so I subtract the r. Negative 30 is greater than or equal to 42 plus 2r. Go ahead and subtract, Go ahead and subtract the 42. And you get negative 72 is greater than or equal to 2r. Then divide both sides by 2. And you're going to get negative 36 is, do I flip the sign? It's negative. No, because what I divided by was a positive 2, so we keep the sign the same, and this is what we have. Do we like the way that looks? No, so we're going to pick it up. The arrow was pointing to the r before, so we're going to make it still point to the r. So this is your answer, and then how do you draw your number line? Put negative 36 on the number line, close that dot, or put a bracket, doesn't matter. And r is less than or equal to that, so that means I want all the values below it. So it doesn't matter if you have a dot there or a bracket. It means the same thing. Okay, so those are just regular inequalities. What about compound inequalities? A compound is an inequality is any inequality that has an and or an or. An and or an or. Okay? I had the wrong or. Okay? An and. So important. An and says you must find all the values that make both inequalities true. Your keywords means trapped or overlapped. So anytime you see an and, your and is going to be an overlapping graph. An or must find all the values that make one or the other inequality true. These are always opposite directions. These are always going to look like opposite directions. An example. So here we go. I give you these compound graphs, and we actually have to come up with how to write them. So this right here is the first example is only going one direction. So I'm going to go ahead and put my shade on here so that we can see this a little bit easier. Okay. Come on. Please don't do that. Whew. Thought I was going to quit on me, guys. Okay. So this right here, the shading is also left, so I'm going to talk about what x is. X can be any value. I'm comparing it to 3, and the shading is which direction for the 3? The shading is below 3, so I'm going to have less than. And then I ask myself, is this going to be an open dot or a closed dot? It's an open dot, which means it's strictly less than. So we go to the next one. Same concept. I have x, and I'm comparing it with negative 4. The arrow is going to go which direction? It's going to go to the right because all the shading is to the right. However, this is a closed dot. Closed dot means I have to include the negative 4, so therefore it's x is greater than or equal to negative 4. Okay, this one right here is an example of an or statement because you have basically two graphs here. So if I look at the first one, I'm going to look at the very first one on the left, and I'm going to say x is going to be compared to negative 1. And x is the shaded region, so that's to the left of negative 1, and it's an open dot, so therefore it's strictly less than. Then you're going to add the word or, and then you're going to do the other side. X is going to be, in this case, compared to 1, but it's going to be going shading to the right, so it's greater than, but it's a closed dot, so it's greater than or equal to. This is your whole answer there. Okay? Let's do this one. This is an example of an and, where it has a significant starting point and a very specific ending point. So what this means is I'm going to put up the starting point, and I'm going to put up the ending point. And x is the shaded region. And then you're going to say, well, what is negative 6 compared to 4? Well, negative 6 compared to 4 is always less than. And then you're going to ask yourself, are they closed dotted or open dot? At negative 6 is going to be a closed or an open dot, so I leave it. But at 4, it's a closed dot, so I have to put the less than symbol. When you use and, you are always use the less than symbol. Always use less than. So, same thing here. This is a trapped one as well. They overlap one another. So I have negative 10, I have x in the middle, and I have 7. I always use the less than symbols, and I have to ask myself, is this going to be solid or dotted at negative 10? It's solid, so therefore I put the less than or equal to symbol there. At 7, it is going to be strictly closed, is open, so therefore I leave it just like this. Okay? And the last one here, the whole entire line is shaded except for negative 3. That means x can be any number, but x cannot be negative 3. So that is how you're going to do part of your homework tonight. Now let's actually do a compound inequality. A compound inequality is going to look like this. Okay? So basically what you have is you have two problems here. You have this problem. So what would you do if you had this problem? If you had this problem, you'd simply distribute. So 6x plus 2 minus 5 is less than or equal to 11. Well, think of it this way. This problem over here would be exactly the same way. So you just keep doing what you would do to one side. So now what would you do here? Now you would combine like terms inside. Well, over here, you would do exactly the same thing, dropping down the 11. So we're just going to keep working both sides of this as we go. So how do I get rid of this 3? I get rid of this 3 by adding 3s to the left, the middle, and the right. So 0 is less than 6x, which is less than or equal to 14. 0 is a number. You have to keep it. You can't drop it off. This number right here is the biggest mistake with many students. They drop the 0 because they don't think it matters anymore. The 0 is a number. You can have 0 debt. You can have $0 in your pocket. It is a number. You must keep it. So then I need to go ahead and divide the left, the middle, and the right by 6. 0 divided by 6 is 0. And then 14 over 7, divide both of those by 2, that gives you 7/3. This is done. How do I graph this? Put 0 here, put 7/3 there. It is opened at 7, it is closed at 7/3, and you shade in the middle. Next, still a compound inequality, but there are two different equations, which is why we have to solve them separately. So if I subtract 1, I have 6 is less than 2x. Divide by 2, I have 3 is less than x. Over here, if I divide by 3, I have x is less than or equal to 6. So do yourself a favor and put these on a number line. I have x, I have 3, and I have 6. At 3, it is open, and this says that x3 has the arrow pointed toward it. This says that x is greater than 3. Okay, the next one says that x is going to be less than or equal to 6. So what do you notice about this? I want all the values where x takes on that makes this a true statement. So I only want where both of them are true. So the only place where both of them are true are going to be in the middle, which means I have 3, x in the middle, and 6. I always use the less than symbols. However, I keep just strictly the less than of the 3, but I put less than or equal to over here for the 6. And that is the correct answer, and that is a trapped or overlapping region. So that's how I know I was right. Do we all understand that? Next, same exact concept. I divide by 9. I have x is less than negative 3. And divide by 4. X is greater than 9. Now this is an and. So if it's an and, I need both of them, and my brain needs to think, okay, well that means overlap. So if I put both of these on a number line, I have negative 3 here, I have 9 there. At negative 3, it's open, and it says x is below. At 9, it is open, and x is above it. Which region will I accept as my answer? I need an answer where both of these are true. Well, never will I ever have a region where both of these are true, which means this is simply no solution because they do not overlap, and that's what I need them to do. This is an or. Or I subtract 7, and I have x is greater than or equal to negative 1. Or subtract the 8, x is less than negative 5. So if I put these on a number line, negative 5 is below negative 1. At negative 1, it is a closed dot, and I'm shading above it. At negative 5, it is an open dot, and I'm shading below it. So if that is the case, my answer that I'm going to have, the or means I can satisfy one or the other. That means I simply am going to, sorry, I have the wrong marker here. I am simply going to combine both of these, starting from left to right. X is less than negative 5, or x is greater than or equal to negative 1. You always want to go from left to right. Left to right. Okay, another one. Divide by 3, x is greater than 1. Or divide by 9, x is less than 6. Okay? Here's 1, here's 6. If I'm talking 1, it's open, and I'm shading to the right. If I'm at 6, it is open, and now I'm shading to the left. Now I want to know what number will make one or the other true. Didn't I just basically color the entire line? That means any number in the world will work. X is a number of the reals, and it doesn't matter what number I plug in, it will work. Okay? So, let's keep on going here. This is the last problem we have before you start your homework. So what are we going to do here? This is an and, it's trapped, so I go ahead and I drop everything down, and I distribute the negative 2x into the parentheses. I'm going to go ahead and combine like terms in the middle, so 3 minus 8 gives me a negative 5. Then I'm going to go ahead and I'm going to add 5 to the left, to the middle, and to the right. So negative 1 is less than or equal to negative 2x, which is less than or equal to 8. Then I'm going to divide the left, the middle, and the right by negative 2. When I divide by a negative, what do I have to do? I have to flip the inequality sign. Now, 1/2 is greater than negative 4, but we always like to put the smaller number first. So that's negative 4 is less than or equal to x, which is less than or equal to 1/2. This is what your brain should see and what you should have. And if I were to graph this, here's negative 4, here's a half, x is trapped in the middle, and they are both closed dotted, and you shade in the middle. Tonight's homework is going to be Chapter 1.5, Worksheet 1.